So, good evening, all. Uh, Good evening, all. We have started the live session class 3 on that chapter sensor and X2D. In this course session, we have to learn about and familiar with that MEMS basic sensors, fabrication steps, wire bonding, and PDMS. What is the instrument of the clean room? How to operate the clean room, and one thing more that. Whatever the instrument we have used in the clean room to fabricate our sensor and MEMS based devices. So, so we have to we have few questions for you. I have prepared. So I think that participants should be response by unmuting yourself. So first question is what is the fundamental working principle of the sensors? So what you understand by the sensors? Uh, so Sensors fundamental working principle is a conversion of the one form of energy into another form. I already discussed with the first class and second class about the how to sensor will be worked, what type of the sensor, what is the performance parameter of sensor, and everything that. So second question is a biosensors required. If we have to fabricate the biosensor and or we have to biosensor. Shankar, are you there? Shankar.
Yes,
So
yes, sir.
okay. So, uh, can you tell me that what is the fundamental working principle of the sensors? It
No
is your
idea.
first class?
No idea,
It is
sir.
your first class? Yeah, you have to join the first one today. Last you have to join. Last two class you have attempted, or it is first class?
Sir, last class attempt in 10 questions when my network issue, so I leave it. I
Okay.
don't join.
So that Arpita ma'am class you have joined.
Yes, ma'am. Yes, sir.
Okay, okay. So actually, Arpita ma'am will be take the questions and answer of basic questions like that, and even I have also tell you about that more detail about that. Theoretical as well experimental part of that sensor and actuator. Okay, so he told you that what is the sensor will be, how to sensor will be work and everything.
Yes, sir. Yes, sir.
So what is the definition of the sensors? Can you tell me? So actually the sensor is a device.
The
It is
sensor is a physical data collect, convert electrical signal, give the system.
so, no, the sensor is a device which sense the physical stimuluses and convert one form of energy to another form. Like that, you have the pressure sensors. So what if the pressure sensor will do? It will be sense the pressures and it convert into the electrical signals, and that signals will be readable by the our systems, which give that how much the pressure will be imply on that systems. So like that, in the car we have the pressure sensor. So when the car will be strike or accident will be happen, the pressure sensor will be sense that how much the pressure will be put by the during the accident, and during these pressures that car accident will be happen or that will be happens. So to measure the pressures or to measure the concentration of the toxic gas in the environment or anywhere room, we use the sensors. So sensor basic principle is to sense the physical stimulus. Physical maybe that is the temperatures, humidity, pressures, uh, thermal, electrical, magnetical, sound, acoustic, light, anything that possible in that. So our sensor will be detect to anything, any physical stimulus. So second question is the biosensor. Have you why the name is the biosensors? Can you tell me that? Hello.
No, sir. No idea. No idea, sir.
By name that already defined that bio means biological things can be sensed by like that DNA, protein, neutron, that asthma molecules, that DTO2, that things will be sensed by the biosensors. Okay, like that. Have you seen any blood pressure patient or like um, or diabetes patient? Hello. Have you know that how diabetes will be tested? Have you any idea? Kirtika? So what if a patients have the diabetes? So we have the one devices in the market that is a portable devices will be available. So like that. So like that. This is the LED display. Here is the one strip will become in that diabetic pressure sensors, and like that. This is the finger of any human being. The blood will be we put the two droplets of the blood on that strip, and this strip the test the diabetes of the patient, and here diabetes will be displayed that this is 200, 300, 400. So this is the there is a one sensor which sense the diabetes in the patients. So biosensor will require biomolecules, electrochemical compounds, chemical compound to work, or pressurized reactor. What things will be required to sense the biosensors? Kritika, are you there? Kritika. So we require to sense the biosensor, like the biosensor require the biomolecules. Otherwise, it will be not sense the electrochemical compound, chemical compound to work, and pressure sensor. They have the different type of sensor. Electrochemical sensor is a different, chemical compound sensor is a different. So to sense the different physical stimulus, we have to fabricate the different kinds of sensors. Third question is the a device that converts one form of energy into another and provide the user with the usable output in the response to a specific measurable input is known as. So what is the name of the device is that convert the one form of energy to another form? It is a sensor, microactuator, microelectrodes, or CJ processor. So answer is the sensors. Okay. So sensors will sense the one form of energy and provide a user with the usable output in the response of the another form. Any material that has change of the electrical property after being exposed to particular gas can be used as a like that. We have the material. This is the silicon substrate. Here we have the material coating on silicon substrate. Some material like that oxide material, metal oxide material, or semiconductor oxide material. So like that there is a maybe ZNO, TiO2, SNO, lot of the material that available in the periodic table we use for the sensors. So when the gas like that, when the H2 is the gas, their molecules will be exposed on these materials, and what happens When the gas molecule will be exposed, it react with the ZNO, and the electron or hole transformation will be take place. So due to that, the conductivity of the current or resistance will be decrease of that material, semiconductor behavior of the material. And we whatever, without the gas we measure the current IV characteristic, and with gas we measure and how much the change in the current we can predict. And they say that on this ppm, that the gas concentration measured in the parts per million ppm, like the 50 ppm, 100 ppm, 1000 ppm, we can apply on that sensors. And according to the current will change with the concentration of the gas. So we measure. So the question is, any material that has changed the electrical work being exposed to gas can be used as a gas sensors. That will be chemical sensor. We use as a chemical sensor because the principle of the gas sensor is the chemi absorption or physi absorption. Means reaction of the gas molecule with the material, means the chemical reaction will take place, or physically absorption of that atoms on the available on the surface of the oxygen. That will be reason that this sensor will be used as a chemical sensors. What is the biosensors? We use the biomolecules like the blood, DNA, protein to make the biosensor. What is a thermosensor? That will sense the temperatures. What is a piezoelectric sensors? It will change the pressures. That piezoelectric material, that there is a random orientation of that materials will be there. Due to that, any electric field or magnetic field be strike on the material, that behavior will be change of that field material. Either it will be behave as a piezoelectric like behavior, or pyroelectric like behavior you have read in that material science. And we use that sensors. Pressure sensor work on the principle of, so pressure sensor will work on the principle of deflecting at a thin diaphragm, heating a thin diaphragm, magnetizing a thin diaphragm, or cooling a thin diaphragm. So what will happen in the pressure sensors? Pressure sensor like that, you have the sound system. Okay, and there is a one diagram in the sound system, like that structure. We have the diagram. There is electric material. When some sound will be pressurized on diagram, or means it will change its property of that material. At sound, that pressure will be sensed by this material, and sound will be converted into electrical signal here. And then electrical signal will then again converted, some converter is there, and again convert into sound from outside. Heating a thin diaphragm means this will be a heating of that. Magnetize means magnetic field will be there. Cooling in the thin diagram, so we have to depleting a thin diagram. Means the depletion will be happen due to the pressures that will be sensed by the pressure sensors. So answer is the depleting a thin diagram. So all the sensors and devices are now, technology will be based either nano sensors or microelectronics, microelectrochemical mechanical system based sensors. MEMS full form is microelectrical electrochemical mechanical systems. IC means integrated circuit. So how do we fabricate these sensor? Flow of the fabrication. What is the steps we have to follow the fabrication of the sensor, like the gas sensor, pressure sensor, or actuator or transducer that will be used in our system. We have the complete system of the MEMS, like that we have the CPU in our system, or our sensor we want to enable with the IoT or AI or machine learning. So we have to integrate our sensor with that processor or that system, IoT based system. So first we have to fabricate sensors. So what is the steps we have to follow to fabricate the sensors? So process of the IC and MEMS are almost same. Means integrate circuit or micro, that both the process we have to follow the same. Maybe some materials be different, some contact, electrochemical contact may be different, and size may be different, but we have to follow the same step whatever the integrated circuit we use to MEMS. Process complexity yield depend upon the repetition of the central loop. So whatever the process we have to follow, and what is the complexity of that process, either it is difficult and easy to fabricate, it depend upon the repetition of the central loop, how much time we have to repeat, and how much the accuracy and sensitivity of the device we have to require. So this is the system. We have used the vapor, then we have to deposit some material on the vapor, then we have to do lithography, then we have to etch, and then this will be form the ships. So what is this? Everyone have seen maybe silicon vapor, or they have familiar with that SiSiO2 vapor will be available in the market. They, if the someone have the read the in the their BTech and MTech that subject as CMOS technology, they have to read about the silicon vapor, that how we manufacture silicon vapor, that CZ process ignite will be used to make the silicon vapors. So their structure will be ignite like structure. I will show in the next slide that how silicon vapor will be manufactured. So we like that. This is the silicon vapor available, and then we have to deposit some materials. There is many technique to deposition of material like CVD, that chemical vapor deposition, pressure pulse laser deposition, MOCVD, MOCVD, atomic layer depositions, hydrothermal methods. So we can deposit the various materials to make the sensors. So we have to choose which material which give the that sensor that is suitable for the temperature sensors, that is suitable pressure sensor, gas sensor, light sensor. So according to their electrical, optical and mechanical property of that materials, we have choose for that particular applications. Okay, recently like that gas sensors, we use the 2D materials or metal oxide materials to sense the gas. For pressure sensor, we use the piezoelectric materials. For thermal sensor, we use that material which have the high temperature coefficient, that property. For magnetic, they have the superconductor like that material they we use for that for sensors. For optical and light, the material that sense the light. So we have to use the absorption and UV visible of that material and see that which wavelength that material will be absorb more number of that light and give that electron and hole pairs. So according to our application, we have choose the material and deposit. Whatever the quality of the sensor, we use the different method: sputtering, ALD, LPCVD, CVD, TCVD, hydrothermal, sol gel method. There are different method are deposition available. Lithography is the tool which used to make the pattern on that device. Like that, we have after that deposition of materials, we have to make the contact on the devices to measure the change in the current or physical stimulation on that devices. We have to deposit either aluminum contact, gold, chrome, silver, whatever that requirement and cost of the materials, we use particular metal to deposit on that material to make the electric current. Then we have to etch that whatever the extra material we have to etch means remove that material from the surface. So etching, maybe the dry etching, wet etching. So we have done etching. In the dry etching we use the plasma treatment. In the wet etching we use the acetone, ethanol, methanol, di water as per their removal of the material. And then we have to fabricate the packaging of the chips. So as that we use the silicon vapor fabrication process, we use the Kozarski process widely used to make single crystal. So this is the single crystal that silicon will be melt, and it will be found that quartz crucible there single and carbon heater will be there. So this type of that silicon vapor will be and this is after that process, and this is the fabrication facility they use to fabricate the silicon vapors. Any questions? Anyone have any doubt? Kirtika,
No, sir.
have
Have
you
you been
in your,
in your? Yes, sir.
have you seen
Have you
silicon?
seen silicon? Yes, yes.
Where?
Where? Yeah, yes, sir. Please repeat your question, sir. It is not listenable properly.
Have you
Have
seen
you
silicon?
seen silicon? No, sir, no.
Which college you
Which
are?
college you are? Not college, university, Pondicherry University.
Pondicherry
Pondicherry
University.
University. Yes, yes.
So
So, almost completed this year.
you are in the
you are in the
BTech.
BTech. No, no, MTech.
So have you that that there this is
Silicon wafer, sir. No, sir.
no, no, this is the part that doing silicon
Yes,
great.
sir. It is not listenable, sir.
Actually, anyone any the fabrication.
No, sir. I don't
Your
know the lab process or anything.
any fabrication.
No, sir. No.
So your MTech is
Is he?
no topic that MTech thesis type.
Yes, sir.
MTech thesis type.
Thesis title is the actually it was the optical sensor, PCF sensor, PCF biosensor. Actually, that for
So
measuring that optical properties and the sensitivity with I mean with surface plasma resonance based sensor actually, sir.
so you are doing simulation or
Yes, yes. I simulated the existing system in COMSOL Multiphysics 5.5, and then I proposed it was titanium coated model, and I proposed in my proposed work I proposed on the same structure with gold coating, and
in place of the type is the gold.
yes, sir.
In the place of the type is the gold.
Yes, yes. Only that, and
What
numerically.
substrate you use?
Yes, sir.
What substrate you use?
Substrate only, it is only numerically investigated. I mean, only software simulation was there, not
Yes,
any.
but any substrate you use that and have deposit link of that of both.
Mm.
Then you are simulated
Yes, yes.
like that. You have to in that you have to take that one, and then you have deposited
Sorry, sir. I
what,
cannot listen. I cannot listen properly, sir.
like that. This is the substrate.
Yes, yes.
Then you have deposit gold. Here you have
No,
taken
no. Actually, I took the cross section of the sensor. I designed like that in console multiphysics 5.5, and on that in the bottom side, on the I mean the PML layer, on PML layer bottom side, there was one coating of uh, I mean one coating of gold, and then the analyte layer.
you this is layer, and then you have to put gold.
Total, it was a D-shaped cross section was D-shaped, and fused silica was used in core, and there was air holes there in core, and in PML also the fused silica, and in the bottom side first the coating of titanium was there in the existing model, and in my proposed model I used the gold in coating, and after that the analyte was placed. I
Okay.
tested for skin analyte only.
Skin means human skin.
Skin cancer analyte only.
Okay, skin cancer. So you make the place of
Yes, sir.
you make the bias.
Yes, sir. Actually,
So,
all was made only the coating type. Plasmonic coating was changed in my proposed model.
so what is the it will be improved in the company or it will be
Improvement.
yeah. How much the company with the PC or EU?
After simulation, I got actually in the present system it was the sensitivity was 500 uh, 500 the wavelength sensitivity was for the skin and light, and for using the gold it came 20 something,
Only 20.
20 100 something.
20, 100.
Sorry,
So
something, some
which
mistake is there.
wavelength?
5,000, 5,000 and 20,000 it was like.
Okay, 5,000. Which wavelength you use?
Yes, sir.
Which wavelength of light?
Wavelength, actually we take up. parametric sweep for that experiment, and
Hmm.
it was from point to 5 micrometer.
Okay, point
And
five to 0.5 to
uh, and for that we plotted that graph and graph in Excel, and for y polarization only, and for the both cases the only the wavelength sensitivity was measured. That was the total project.
Okay, so what is and selectivity?
Yes, sir.
What is
Cannot listen.
how you can define?
Cannot listen, sir. Sorry.
Can you define the
Selectivity, sir.
sensitivity?
Sensitivity is delta lambda divided by delta n. Delta n is the difference between the two refractive index of this normal skin analyte and cancer skin analyte, and the wavelength means the resonance difference between the resonance wavelength of normal skin analyte and that cancer skin analyte. It was delta, that is the delta, I mean delta lambda peak actually, where we are getting the maximum loss. Confinement loss is being maximum.
Okay, okay. Are you plan to have you
Yes, sir.
in futures are you planning to PhD or have you placed in some
Now only, I completed, but I did not clear any NET or GATE exam. So
but you are the MTech.
yes, I was in MTech from there, but GATE was not clear actually.
So the MTech gate will get you also PhD.
Yes, sir. Sorry.
For if you have done MTech, it will be not required to do the admission for NIT.
GATE is not required, sir.
If you are MTech,
Then JRI for NET will be required, sir.
no, no, not NAT. You have done MTech and MTech, na?
Yes, yes.
So this will get and whatever that.
Okay, sir. Then
You will be admitted
without
to any
NET or
any
GATE, where can I apply for this the
you can
subject
apply
over
to
there?
any NIT, that MHRD.
Yes, sir.
In MHRD, if you apply in the any IT,
Any IIT?
yeah,
Okay, without GATE.
yes, yes, you are the MTech. You are the MTech.
Yes, yes.
You take MTech or the direct MTech?
Uh, cannot listen, sir. Sorry.
MTech admission for GATE score or
They they took one admission test for that in Pondicherry University.
okay, no problem. You have done GATE it.
Yes, sir.
For MTech students, you have to pass the that you have not required.
Sir, it
If
was
you
not
have
clear, sir. I can repeat, please.
if you have done the MTech, you can apply to PhD admission in any.
In any IITs.
Yeah,
And the marks criteria is there in any, any marks, any lowest cutoff marks is there.
they have not master. They have to like take admission now,
Mm, it is not
and then
clear,
they
sir.
after that you have to proceed.
Sir, it was not clear. Again, please repeat.
After the field assessment, you have to appear the research.
Admission test will be there.
Yes, yes, will have the system assessment.
Okay, okay.
And then after the system, you have to appear for the exam.
It sounds it is becoming late.
After the entrance exam, if you are shortlisted, then you have to go to interview.
Sorry, sir, I cannot hear anything. It is.
Actually, if you apply for the, you are for poly.
No, no, I am from Kolkata.
Okay, so if you apply for the Guwahati,
Okay.
or you have to appear for the mission exam.
Yes.
You have to appear for the mission examination.
Um,
There will be test, will be admission.
yes, sir. Okay, okay.
After the test, they will declare the shortlist candidate for the interview. Hello?
Notification already came, sir. No, or
Maybe that
I have
will
to
be
search.
nobody has not even started in the night. So you have regular admission.
It is totally. Actually, I cannot hear anything.
Actually, if you want to check the website, admission intake quality for best of the July.
Month of July.
Yeah,
Okay, sir. Then I will search.
yeah. So you need to search it by and which department you want to apply. If you are working in biotech, so you can start this fabrication facility or you want to focus
Sir,
on the simulation.
sir, sound is not clear, sir. It is not listening, sir. I cannot listen
Like that, your
anything.
interest in sensor and fabrication, design of the sensor.
Sir, I cannot hear, sir.
Hello?
Yes, sir. Now it is clear, but it was not previously clear, sir. I cannot hear.
Okay. So if you are interested in sensor,
Sorry,
hello?
sir. Sorry, sir. I cannot listen
If
anything.
you are interested in the sensor,
Yes, sir.
so you have to search the IIT which faculty you want to sensor.
Yes, sir. Yes, sir. It is not clear, sir.
You search the faculty member who work on the sensor, but
Okay. In which IIT, sir?
whatever you like that. If you marketing IIT, you like IIT Bombay, IIT Delhi, IIT Kanpur, Kanpur, you have to apply in the IIT.
Okay.
Okay.
Okay, sir.
So, and we have to choose the faculty and department that people want to buy.
Okay. Send.
So, if you, yeah,
And then in the month of July, the notification will be coming.
no, no, notification will start in the month of July.
Okay.
July, that PhD will be starting. Your interview exam will be happening in the month of May.
Month of.
April or month of May.
Okay. Okay.
They have start the process on the month of May after application,
After.
filling of the application.
Oh. Okay. Okay, sir. Okay, sir.
So
I will search.
application process is already started.
Okay. In
So you
all
have to,
IITs. Oh.
yeah,
Okay,
all
sir.
IT.
Okay, sir.
So you
I will
have to
search.
apply.
Okay, sir.
Okay.
Okay, sir.
Okay.
I will search and apply.
Yeah.
Thank you, sir.
So what we use previously you've seen that we have to read about that fabrication step of the MEMS. So in the next slide I have put the schematic diagram how the fabrication step will be happen. So like that we have one silicon wafer and to make the pattern on their devices like this type of the pattern. So this window will be open and there is a some material either gold or chrome or nickel whatever the material used for the electrical contact we use. So we use the spin coating to deposit the photoresist. The photoresist is the material which enable the expose of the UV light or create the pattern on the silicon vapor or the materials. So this is the diagram of the spin coating. You can see that he will put that one silicon vapor and there above he put the photoresist. So viscous liquid will form on the center of the vapor like that. This is the center of the this is the vapor we have. We put the drop of that viscous liquid here on the center, and then we have to rotate that machine. Vapor will be spin 1000 to 1500 rpm for 30 second thickness control. So we have to rotate like that. This is the deposition palace. The figure will be explain you how the deposition will be palace. So this will be uniformly, this will be deposit spin off or evaporation, or this spin up process will be taken, and this photoresist will be deposited uniformly all over the silicon vapors. Bake on the hot plate. Bake means after that deposit the photoresist. This is the hot plate. We have to put our silicon vapor on the hot plate, and for 80 to 1500 degrees Celsius deposit, depend upon the property of the photoresist, what type of photoresist we use. So photoresist will be two per type, that is either positive or negative. So different manufacturer company will be, uh, produce the photoresist. So it will depend upon the photoresist how much type we have to bake on the hot plate. Application of the HN and solvent and resin, and deposit of the polymer sol gel precursor, we use the spin coating. So this is the one instrument we use to deposit some material on the silicon vapor during the fabrication of the sensors. So this will called as the spin coater. So this is the step fabrication process of the micro heater, membrane and chamber, and bonding process for liquid injection purpose. So we have to, that application of the, we have to fabricate the micro heater, membrane and chambers. So what will happen, there is a PR coating and UV exposure. This is the silicon vapor, and this is the blue will be PR coating, and this is the shadow mask through which we have to expose the patterns. So this will be chrome and PT metal deposition. This on that green and red will be chrome and PT metal deposition. After etchant, it will remove, and this red and yellow will be your chrome and PT metal deposition. Final heat structure will be there like that structure. So what we had a PR coating and UC exposure for that. This is the silicon nitride we have to use, and through the KOH is a agent which remove the N exposure area of that light. So what we have to do, first we have to take the silicon vapor on which we have to, this is maybe silicon and this will be maybe some oxide, that insulator metal SiO2. Then what we happen, on this material Si2 we deposit some photoresist through the spin coater here, and then this material we have to, this photoresist material we have to expose to the UV light. We have put one shadow mask here. They have some structure which we want to pattern on there. This UV exposure light, if either it is a positive or photoresist depend, it will be react with that photoresist and make it soluble to the solvent, or pattern will be transferred on the cement. So whatever will happen, if the there is positive photoresist, according to that sensor will be pattern will be exposed on their devices, we have to fabricate it. So you can see that after this, this is the bonding we have used. So you can, the yellow is the platinum, red is the chromium, and then the blue is, this is the blue is the photoresist, this is the glass substrate we have used. So adhesive bonding process will be take on the glass silicon substrate. We have to take the wires from that silicon vapors, and we have to take the bonding, that we have to make the chips of that, sorry, of that devices. So after everything we have to fabrication and bonding, we have take the photograph and same image of the fabricated thin polymer membrane and silicon based micro chamber. So this type of the structures, this is a gold platinum electrode, and on below this structure we have to deposit on that. So this is the final image of our devices we have to fabricate it after everything that. So this is the computer, that system, you can see that image, that this is the interdigital electrode type, that this is the heater we have to fabricate it, and this is a diffusion wall, heater chambers, heater connector, and tubing controller, everything will be there. And this is the measurement of that heating element. We have to supply that, supply and heat that element, that gold and platinum, and heating will be, that it will work as a heater, like that hot plate you have to see, or oven you have to see. So like that oven, this heating will take place, and we measure the temperature, at how much temperatures it like that we have to provide a biasing of 1 volt, 2 volt, 3 volt electrical supply, and that filament of that pt and chrome that this is made, it will be heat through the biasing potential, and temperature will be increase of the substrate. So another topic is sorry. Another topic is micro machining. What do you mean by the micro and machining? Micro means 10 to power 6 minus meter, and machining is the process which fabricate the devices up to dimension of the 10 to power minus 6 meters. Okay, nano machining means 10 to power 9 meter of that physical parameter of the devices. So machining of micro part is not literally correct. Remove of material in the form of chip or debris having the size of the region of the micron means it remove the material from the chips in the micrometers, creating micro features or surface characteristics, especially surface finish in the micro and nano level. So whatever that patent will be transferred to our devices, structures like gate source and drain or gate we have to fabricate it on the devices. Like someone want to fabricate the CMOS transistors. So CMOS have like whatever the CMOS like the structure, whatever CMOS structure. This is the source, this is a drain, we have one oxide layer, and there is the gate. Okay, so this is the source, this is a drain, and this is the gate. So it will not the machine come in the micrometers, whatever the dimension of that source, gate and drain that open through the lithography, and that will be in the micrometers. Okay, this will be in the micrometer length, the distance between source and drain in the micrometers. So that's why its name should be micro machining. Definition: material removal at micro nano level with no constant or the size of component being machined. Why micro machining required? What is why we need a micro machining? Because we want to reduce the size of our devices, because in the 21st century, as per the increment the technology or new generation technology will come in the market, we require a less area of our devices that occupy, and performance should be more. So that's why we have to fabricate our devices of dimension of the micrometer or nanometers. So final finishing operation in the manufacturing of precise parts are always of the concern, owing to their most critical, labor intensive and least controllable natures. In the era of the nanotechnology, deterministic high precision finishing method of the utmost important are a need of the present manufacturing scenario. Means whatever the technology, nanotechnology we have now, that require the high precision method. Means we require less number of the defects in our devices, and suppose we want to make that source and drain of the 10 micrometer, then the technology we use can make the source drain make of the 10 micrometer only. So we require a high precision of utmost importance and the need of the present manufacturing. As the present scenario of the manufacturing we require, according to that the need for the high precision in the manufacturing was felt by the manufacturer worldwide to improve the interchangeability of the component, improve the quality control, and longer wear fatigue life. So, whatever the requirement of the new technology, we required less defects, long life of that devices, and we have to change the improve the quality of that devices. That's why we use the micro machining. So present day high tech industry design requirement are strange. Now, have you heard about that? Our CPU will be based on the 3 nanometer technology, 5 nanometer technology, 7 nanometer technology. Someone have read that our 5G and 6G technology based on the 3 nanometer skills. You have, if you have read a newspaper and if you are touch with the technology, what are the latest technology will come in the market, that 6G and 5G chip will be based on the 3 nanometer technology. Means the device size of that size will be the 3 nanometers. So present a high tech industry like that Intel, AMD, that will be manufacturing the chips, Qualcomm. They are the industry which are involved in the fabrication of the chips, and the chips will be fabricated in the China, Taiwan, USA. And you know that in India that every component we have to brought from the China, because the cost will be very low, and we have the not the facility to even the fabricated of the single transistor in the India for the industry level. We can fabricate it in the research lab, but we have no fabrication industry still here. So government of India have come with the scheme of the manufacturing some that semiconductor manufacturing industry, and they are started the work on that to how to bring that semiconductor in the India to fabricate the chips. And already that Vedanta have announced in the Gujarat they have to open one plant for the fabrication of the chips. So we need the extraordinary properties of the materials. ठीक है ना? Why? Because our material property will be not changed after exposure of the UV light or treatment we have to done to transfer the patent on our devices. So we require a high strength, high heat resistant, high hardness, corrosion resistant, extra. Complex 3D component turbine blades. If you see that blade of the turbines, which we use for generation of the energy, or turbine pump will be used in the aircrafts and everywhere. So what are the blades their design, you can see that they require a complex 3D component. Okay, if you see the gearbox in the any car and any equipment, how you can see how the complexity of that gearbox and how they manage and package that gearbox. So that's why we require the micro machining. Nano level surface finish of the complex geometry, making and finishing of the microfluidic channels. So in the, if you anyone in the mechanical background, there is the microfluidic channels. Means Kirtika, are you working in that biosensors? So many people want to inject a drug into the human body. So they, what will they use? How much the dose will be required to insert to the human body? So they use the one microfluidic channels in which they fill that dose of that medicines or everything, and they will be passed in the body according to requirement. We will control the dose of that automatic through the machine. We have to control that dose. So we require the microfluidic channels for that, and this will be on the MEMS based devices, or that microfluidic channel will be used in the hydro industry, power plant industry, to flow of that materials through the machines. How much the flow will require the output, input, and that through will be possible through the microfluidic. They have the, they make the channels. So we have the different micro machining technique, that photolithography, etching, silicon micro machine, Liga, and mechanical micro machining. So in this subject, we aware about the micro photolithography and etching. We have to focus on that photolithography. This photo and litho. This is the Greek word that use the transfer of the patterns. Photo. like that. Have you tried that someone? Have you wear the printed T-shirt? Hello, hello, Aswini, are you there? Kirtika.
Yes, yes, sir.
So in your college, some fest will be happen, and some will be printed hoodie and that. How they will be printed some logo or name on that T-shirt and that hoodie. What technology they have use?
I don't know, sir.
If you want to print your name on the T-shirt, they will not return the through that like that printer will be not return anything that. Have you wear that printed T-shirt? Hello, Aswini, Kritika,
Yes, sir.
have you wear the printed T-shirt?
Yes, sir.
Have you that printed cup, mug and coffee mug cup that we have to printed some logo or something that, or anyone have to gift you like that your girlfriend or like that printed T-shirt that some people are using that to paste their photo to gift someone that as a gift.
No, sir.
Huh? Have you the printed coffee cup with you? Anyone?
Yes.
No.
No.
Kitaka you have?
Yes, yes.
So what is printed?
I don't know. No.
Means some photo name, some sign will be there. Okay. So what the printing people will do, they will make the that copy in the computer. Okay. And there will be machine on that computer. They will put that our cup or on that machines, and just they paste on that our system and transfer that photo to the our T-shirt or that cup. Okay. So what will photo lithography means transfer of that photo to our devices. Okay. So photo lithography will be same that people are using, but they are using on the large scale, but our device size should be the small. So we use that photo, that exposure of the UV light, we like that like that this logo we have to print on that our system, on that system. So what we happen, we make the mask of that logo. Okay, or any design. Suppose that this is my design. This design I want to pattern on something on this. So what happened, I put mask on this. This is the PR coated paper. Okay. And then I will expose the light. So what will happen, this pattern will be transferred on these materials. And after where will be this will be uh, this is a material, this is the pad. The pad will be transferred on that, and when I deposit any electrode or gold or contact, this this will be I remove through the etchant. Etching will be done like ethanol, methanol, acetone. This PR will be removed, and this will be remain in that. After that electrode chemical removal, and then this layer will be removed. After that last process we have to remove this photoresist also, and only this gold contact will be remain on that substrate. It means we have to transfer this structure to our devices as per our desire. So this is the photolithography. You can see that this is the light, UV light. This is the lens which condense all the UV light. This is a mask. So they have deposit rectangle on that silicon wafers. See that. So this light will be exposed and this will be pattern transferred on the silicon wafers. This type of structures. So this is the photo we have used and we have to transfer on that silicon wafers. So what is the step to use the in the fabrication facility? Fabrications. What you understand by this figure, this PPT, this something what you Means, can you analyze these steps? What is your understanding from to see this figure? What is come in your mind? What things come in your mind? Can anyone tell me?
Fabrication is done step by step. First, it is cleaned, then the photoresist is coated, and then substrate is coated. Usually, the oxide or something is deposited. Then, photoresist is coated on that in third step. After that, UV exposure was there uh, with laser, and then in the next step, um, unexposed resist was removed.
So how we deposit which machine we use
Yes,
to deposit this layer photo?
yes.
So which instrument we use?
Um, I don't
I
know.
wanted to explain last second of last two slide. We use the spin coater here.
Spin coater.
Spin, uniformly coating of that photoresist. So there is a one instrument that spin coater will become, and it will rotate on different RPM. Whatever the thickness required, we have to set the RPM and type of the spin coaters. Like that, I have to deposit 40 micrometer, 40 nanometer of the photoresist. So we have to optimize that on which RPM and which second that 40 nanometer will become, and then we have to go ahead. Then after that photoresist, we have to put one shadow mask which image we have to pattern, and what type of structure we want to pattern on our devices, that we have to put in between that photoresist and that material, that make of the glass substrate. We have to make some patterned structure, and then UV light will be exposed to the pattern. That pattern will be transferred to the our devices, and whatever the exposed area and exposed area will be there, exposed area will be softening due to the UV light, and it will be removed through the acetone. Ethanol, methanol is the chemical we use. Okay, and after that we have to make that deposit lift, or make the gold, chrome or nickel, that contact whatever material we have to require, we have to deposit through the thermal evaporation. Means we have to evaporate some materials, gold, chrome, nickel, or we use the electron beam, CVD. We have some target, and through that we have to transfer that material, and then after that everything will be happen. Then that remaining unexposed area of the photoresist will be removed through the dry etch or wet etching, that either through the plasma treatment, or use we have to use acetone, or that HF material, that acid we have used. So photolithography process description: the vapor are chemically cleaned to remove particular metals, because that vapor we have to brought from the market, there is a lot of the impurity will be on that, and it will be affect the property of our devices. So we have to clean that vapor. So what we use in the cleaning process, we have to put vapor in that sonicator. Is a one another instrument which have a sonicate on a different frequency or different temperature. We have to put DI water or acetone or IPA, that isopropyl alcohol, and on in which we have to dip our silicon vapor, and we put that vapor in the sonicators. Then we have to on the sonicator, and it will be have some vibration molecules energy that vibrate, and it will be whatever the dust particle will be stuck on our vapor, it will be removed through that sonicators. After that sonicators will be done, we have to dip our water in the DI water. DI means distilled water, that have the zero other component, only that water, no impurity in that water, pure water we have to use. After dipping in the water, we have to use either ethanol or acetone. We have to put again in that vaporization. We heat around 80 to 100 degrees Celsius for 10 to 20 minutes, and then we have to again remove, and then we have to again to put in the DI water, arrange with the DI water. After that, we have to blow up the nitrogen, that we have to dry that vapor, because there is a acetone or that ethanol will be there, so we have to dry that vapor. So this will be the cleaning process we have used. High speed centrifugal boiling of silicon vapor known as a spin coating produce the uniform layer of the photoresist, a light sensitive polymer on the vapors. So what we use through the spin coating system, we have to produce a uniform layer of the photoresist, a light sensitive polymer, because we have to expose that pattern in the presence of the UV light. That UV has the some wavelength of either 365 nanometer, 352 nanometers, whatever the UV source we have used, we have to expose. So photoresist is exposed to a set of light through mask often made of the quartz of material. This is a mask that have some pattern which we want to transfer on our devices. Pattern have the different structure, either it is a rectangle, interdigital electrode, circular. What pattern you want to transfer, that structure will be, we have to paste on that quartz glass substrate, and then so wavelength of the lines ranges from the 300 to 500 nanometer UV and X-ray wavelength of the 4 to 1500 angstrom that we have used to expose the photoresist. Two type of the photoresist we have used, positive, whatever so goes, negative, ठीक है ना, whatever so stay. Positive means whatever the area will be exposed, it will be go remove. Okay, and in negative, whatever the area will be so, it will be stay, remaining area will be, we can remove through the acetone and IPA. And whatever the area will be exposed, the photoresist will be remain here, and remaining photoresist will be removed through the edge through the acetone. But in case of the positive photoresist, whatever the area will be exposed in the presence of UV light, it will be etched through the acetone or ethanol, IPA, methanol, but unexposed area will be remain stay on the sample. So this is the schematic diagram of that materials we have used. That light that we have to use, that mask, and there's the photoresist film and substrate. So these two structure we want to expose. These two, these three, is the positive and negative the photoresist. So what in the negative photoresist, this will be removed, whatever the unexposed area will be stay here, but in case of that other exposed area will be removed, only this will be removed, this electrode will be here, that pattern, this transfer it will have. But in case that what white light will be, that will be stay and other will be removed through the edge through that. And this is the edge patterns, we have used the positive and negative photoresist. So from that schematic diagram you can differentiate what difference between positive and negative photoresist. What is the etching? So etching is used in microfabrications to chemically remove the layer from the surface of a vapor during the manufacturing. Etch means hatana, remove karna. Unwanted things we want to remove. Etching is a critical important process module, and every vapor undergoes many etching steps before it is complete. It is characterized by the etch rate, etch selectivity, and etch uniformity. Means how can we characterize by the etching process? Whatever the etching rate we have to require, what is the selectivity that etch material the selectivity, and what is the uniformity of the etch? How much it will be removed? It what type of the area? Means if you use the etch and take that acetone, and it will be removed at a time only 1 micrometer into 1 micrometer area, then this will be S selectivity of the only 1 micrometer wide, and H uniformity, how it will be removed completely 1 micrometer area on 1 micrometer of area. So the process variation, that wet etching and dry etching. Etching process used liquid phase. Wet means we liquid etchant. The vapor can be immersed in the bath of etchant, which must be uh, agitated to achieve good process control. For instance, buffered hydraulic is used commonly to etch solution. So we use the acid and that wet material to remove. In dry etching, modern VLSI process avoid wet etching and use plasma etch instead of the plasma etching. Operate between that we have used create some pressure in between that some instrument that have the plasma facility, that we have to make to system to take that 0.1 to 5 torr pressure using that some rotary pump, and then we have to energize some radical, that we have to use the nitrogen, oxygen, or whatever the plasma required, krypton or that xenon plasma required. So we use some gases, and then we have some RA power supply, radio frequency power supply, that then we have to put some voltage on that, and some plasma will be created, and it will remove striking some plasma atom on the surface, and it will remove that unwanted things from that surface. So what do you mean by the bulk micro scanning? There is a two micro sorry machining. One is the bulk and another is the surface micro machining. So bulk and surface micro machining are the process used to create microstructure on the micromechanical MEMS devices, microelectrical mechanical MEMS. With both wet and dry etching process technique available to both bulk and surface micro machining. Bulk micro machining typically use wet etching technique, while surface micro is using a dry etching technique. So in case if you use the bulk micro machining, to etch the material we use the wet process, but in case of that surface micro machining things, we use the dry, that plasma treatment etching process. Bulk micro machining selectivity etch the silicon substrate to create a, so what bulk micro machining will be as the selective all the substrate uniformity, select as the substrate, and we can transfer the microstructure to the MEMS devices. So another is the surface micro machining. So unlike the bulk micro machining, where a silicon substrate vapor is a selectivity as to produce structure, surface micro machining fluid. So generally we use silicon one of the layer, and silicon dioxide use a solidification layer which remove or etch out to create the necessary void in the thickness directions. So this is the fabrication step. We have the use the silicon vapor. Then we have deposit sacrifice layer, that silicon layer or oxide layer. Then above that we have applied that photoresist, PR photoresist. This is the PR photoresist. This is the SI towards silicon nitride layer, insulator. After that we have pattern. We have to open here pattern, and this is the photoresist will be remaining here. Then we have to do the pattern sacrificial. Again we have to deposit one layer, and then we have to acetone ridge melting. We have to repeat that pattern sacrification. Deposit polysilicon means we have to deposit one polysilicon layer and remove that photoresist. So this layer will be removed, and this electrode will be deposited here. So what, why you require the vapor bonding and PDMS? Okay, so when we have to fabricate the chips like that, this sensor will we have to fabricate it, and this is the electrode, two electrode we have to. So we want to integrate our system with some system like that. This is the big system. So what will happen, this is the, again this is the connection outside that will become on the system. So we put this sensor on here, and we have to bond this material to here, to material, and we take the electrode from here, because the size of this is very small pad, from naked we cannot to see. So to make the contact to make the to supply the electro potential through that electrode, we use that big pad, and this wire bonding, we have to bond the wire either this is made of the silver, aluminum or gold to that pad. So vapor bonding is a process that temporarily sorry or permanently join two vapor or substrate using a suitable process. So these are the two vapor. This is one vapor and this is the second vapor, and we have to join these two vapors together to the wire bonding. Microtechnology involves various types of the bonding process: vapor bonding, wire bonding, and flip chip bonding. So this the three types of the different type of the bonding. So as per the applications we can use. So what is the requirement in the fabrications? We can use different type of the vapor bonding. Sorry. So why we require the vapor bonding? to make the silicon on the insulator SiO2 vapor to create the complex 3D structure and cavity which create device functionality. So if you want to create a 3D structure of device on one structure on another structure above and side and by side, so we require to connect every structure together to perform the our applications. Packaging method to create closed environment, vacuum package for a resonator and for optical and IR devices. So what type of the from that CMOS IC you have to see in anywhere that or NAND gate or OR gate IC or OPM IC used here in the BTech and MTech experiment. So from your bare devices you cannot see that what is the inside in that. There is a one black cap is outside and you can see that some prisons will become outside that. Some legs will become of that aluminum or gold or silver will become outside that packaging, and they are interconnected through that inside that some diode or electrode will be there in that packaging. After that we can use that IC for as a OPM, NAND gate, OR gate or CMOS or BGT or some diode at avalanche photodiode, Zener photodiode in the optical sensing. So integration technology for joining two chips fabricated separately, CMOS plus MEMS. If we one is the CMOS chips and another is the MEMS chips, to connect with these two chips we use the wire bonding because we provide a connection between both these things. Any questions till now? Any doubt? Kritika, Ashwini,
No, sir.
Yes, sir. Yes, no.
anything? Have you understand anything in the issue in my voice or speed is fast? Anything you can tell me? Or if you
No, sir.
need
No,
some,
sir.
okay. Have you gone through that lectures video, professors on NPTEL?
Yes, sir.
So they have put on that clean room 2 video, that video 4 and video 5, how the clean room facility, what is the clean room and what are the instrument used in the clean room. Anyone go through that video? Sorry. So this is the vapor bonding process. You can see the cross section of the silicon vapor, demonstrating branches that can be fabricated using the dry etching. So this type of the structure we have pattern on that silicon vapor. You can see that this electrode, and we use that bonding process. This is the new bonding that reactive process we have used. So method that involves joining or two vapors. So bonding is same process that you have used the welding in mechanical. In the electrical system we use the bonding. In the mechanical we use the uh, uh, what I said that name. What I said that in the mechanical we have to join that two system. What we use that. Uh, if you want to join the two piece of that iron, we use that. What we use? Can you name the technology name that?
It
If you
is
if you
welding, sir.
welding, sorry, okay, okay, welding. Okay, okay. Sorry, sorry. So if you want to join the two iron piece together, what we use do welding. So in case of that, in the electronic system, because this is very small and the size of device is in the micrometers, and because welding is the big process, it requires a big instrument, they no require the precision, we can see through the naked eye, but these devices are very small in the micrometers, we cannot put see through the naked eye. So that's why in the presence of the optical microscope we use the bonding, because paired size in the micrometer, that pair is an 100 micrometer or 200 micrometer or maximum 500 micrometers. So we use the bonding. Three type of vapor bonding: direct bonding, anodic bonding, and intermediate layer bonding. We will go through more about this in the next class or next to next class. So all require substrate that are flat, smooth, clean in order to efficient successful. So if you want to bonding two substrate together, that substrate should be flat. There is a no curve, crack in that substrate. This is smooth. There is no impurity in that clean, that is properly clean. Otherwise, that bonding will be not happen. So what are the MEMS? So MEMS is the micro electrical electromechanical system. Micro electrical means the combination of the electrical and mechanical. Okay, that's why the name is the MEMS. So the devices which have the both the working principle, or both devices together connected, one is the mechanical and one is the electrical. So that's why this name is the mechanical. So mechanical and electromechanical element devices are an structure that are contain size range from millimeter to fraction of the micrometers. Some parts of the devices have some sorts of mechanical functionality. That's why it is the MEMS. Microsystem technology or micro machine technology. You can see that image. This is the micro MEMS microchips. This is the MEMS micro gears. This is the fluid channels that I have already taken to transport the dose and then injected to dose. This is the micro mirror devices. This MEMS headset display. This is handset display. We use the MEMS handset display. So this is the use that electrical optical image, electrical signal, and some mechanical parts that will be rotate on the hand. We have to put on the mechanical part to hold on the hand. To this why they have to name the MEMS handset display. This is the MEMS sensors. This is the MEMS sensors. We have to fabricate it. Have the max plates, feathers, anchor, movable plate, beam. So this is the movable plate. When some things will be exposed on that plate, it plate movement will be take place. Means there is a mechanical principle. And what are the movement of the plate? That displacement will be taken in the form of the electrical signals, and electrical signal will be inserted on the our system, and it will be given in the form of some digital data or some form of the signal in the waveform. So that's why this is the combination of the both the mechanical and electrical. So movable of the plate is the mechanical, and that conversion of energy and form of the energy in the electrical form. So that's why its role of the electrical will be happen. MEMS sensor accelerometer. So whatever the accelerometer will be come in the market, this type of the design will be contained in the accelerometer. This is the MEMS accelerometer. After that, packaging. This type of the chips we have to come in the market. This use the wire bonding, PDMS, and everything. So this is the accelerometer chips. We have some connection here, electrode, and this pad is here to connect it that my materials. See, this is the MEMS operations. Sensor and actuator. Three main type of the transducer: capacity, piezoelectric, and thermal. Capacity means due to the mechanical movement of that things, there is change in the capacitors. Piezoelectric means there is a change in the motion of that electron and material. Thermal means due to the heat conductivity, there is a change in that displacement. So see that this is the all these are the mechanical system based sensors. Another thing is the inertial sensors. So this is the MEMS oscillator we have already, and this is the MEMS gyroscope. Both the combination will be used the inertial sensors. You can see the sensing mass, driving direction, capacitive plates that change that capacitance of that material during to driving, velocity that gyroscope you will be check the velocity of that material, movement of that anything. So why are the commercial available silicon vapor round in shape? This silicon vapor come in the round in shape. That diameter is either 2 inch, either 4 inch, either 6 inch. These are all come in the round shape. Why? What is the reason? Why it is in a rectangle form, square form, triangular form? We have got the silicon vapor in the round shape only. Why? Any reason? Anyone know? Can you tell me the reason?
No, sir.
Kritik, I already explained you the last slide. Yes, maybe Ashwini will miss that. Silicon vapor fabrication process. How silicon vapor will be fabricated, produced? Because we have to fabricate it.
Ignot is actually ignot that is cylindrical shape. So the cutout of that will be in round. So
Yes, yes. So that ignore is the cylindrical shape, and then we have to cut that in the for slices. It will be converted into the circular. Okay. So Kizarowski process will be used to produce the silicon vapor. We have to use the material of the silicon in the crucible, and where we have to heat, and this very fake form in that ignite in the form of. So change in the output of any sensor with respect to change in the input is expressed as what this quantity will be expressed.
sensitivity.
Sensitivity. So what is the difference between the resolution and sensitivity? What is the resolution?
Resolution is a precision. I mean, how correctly it can differentiate between two things.
Okay.
And the formula I forgot, sir, for optical.
So what is the response? Sensitivity and response is the same or different? Response and sensitivity.
Different, sir.
What is the difference? What is the difference?
I don't know, sir. Actually, properly don't know.
Response we have to make difference of the minus out input. So response is the sensitivity is R out bata R in, but the responsivity is R out minus R in bata R in.
Okay, sir.
Okay. So the principle of microfabrication process used in the bulk micro machining is, what is the principle? I already explained you the bulk micro machining. What is that principle? Which used for etching
Sir,
during deposition welding,
Right, 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 right.
which we use. Hmm?
A and B, sir.
Yes, we
Yes,
have to
we have to
define
define
this
this
to make
to make
clear that
clear that
making role play in the micro fabrication devices. So point out the wrong statement. I have put the four statement. Which is wrong? Can you point out me? And what is the reason you have to give to me?
welding is not there.
Yes,
Yes,
welding and
welding and
point out the
point out
wrong
the wrong
statement.
statement. Welding is not there in micro machining.
Yes, yes.
Yes, yes.
From that four statement A, B, C, D, which is wrong?
Side B.
Yeah, Ashwini, which is B? Why? Can you explain? Hello?
Sir, micro means 10 to the power minus 6.
Yeah.
Yeah.
So it is
So
10
it
ki
is
power
10 ki power
10 ki power
10 ki
5.
power 5.
It is
It is
possible?
possible?
Hmm?
Hmm? No, sir. I think
We
we
require either
require either
50
50
micrometers
micrometers per
or
or
below the
below
1
the
micrometer. So,
So,
MEMS are
MEMS
class
are
7 between. This is the wrong statement. MEMS stand for micro electromechanical system. That's the definition of the MEMS. Several MEMS are packaged in the smartphones because the size in the micrometer. So smartphone have some MEMS package system is here. We have the chips of the MEMS in our devices, sensors like that, the temperature sensors we have in the mobile. So it will be weather conditions, temperatures. Some mobiles have that how much the oxygen will be outside, gas sensor will be exhaust in the mobile also. Weather condition will be tell you. So it has some MEMS devices in that. So point out the correct statement. Correct statement. Can anyone point out and why? Ashwini Kritika,
Yes, sir.
which is the correct statement? From these four options, which is correct and which is wrong, and why?
Sir, all are correct.
Why first is correct? MEMS is a class of very small sensor or actuator device, very small mechanical system are driven by the electricity to indicate a positions. The incorporation of the low-cost geosensor in the form of GPS chips into mobile device opens the mobile user to whole range of the service on the client location. The iPhone user uses the proximity sensor to turn the screen off when your system will put phone is on its face. What have you heard about the proximity sensors?
Yes, sir.
So how will be it working on in our mobile screen?
On call mode.
When the iPhone user use the proximity sensor to turn the screen off when users put the phone to his face. So it will be recognize some eye, face, that mirror will be sensor, that mirror will be have some sensors on that. So this is from my side. Any questions? I will show you clean room facility maybe here. Uh, uh, I think that this is not working. Uh, I forget on. So this will be a clean room. What
Class
is the
will
clean
you
room
will
that?
see there there is a glass. Yeah,
Safety cabinet. Hello everyone,
Voice will be
welcome to the course on
audible to you.
sensors and actuators.
No, sir.
Today in this module, we'll be discussing more
Oh,
about an equipment called the biosafety hood. So there are different cabinets
Not is audible, sir.
depending on the containment. Let's get into the details about what is a biosafety cabinet, what are the different cabinets.
voice is audible.
No, no, sir. No.
Not.
Which could be there possibly there in a biological
Yes, sir.
study
Yes. No,
workspace.
audible.
So there are two types of when I'm talking about a biosafety cabinet, this is totally different from a fume hood. So when I say what a fume hood is, it is an environment mostly which looks like the biosafety cabinet. However, the sash, this is called the sash, which would also be available in fume hood. However, the environment why the fume hood is designed is when you are working with chemicals, there could be volatile gases. For example, let's take saline gas. It could release harmful gases. When we are working with such vapor or such chemicals which release vapors or fumes, and in such cases we are supposed to use the fume hoods. So this biological safety cabinet, the BSL cabinet, is different from the fume hood. So that is point one which you need to take care even before you about making you of these. So we are having them in petri dish safety cabinet in a process, the air which is being circulated inside this environment. So the sash here is to protect the person. Here
So
No, sir.
what he explained? Uh, that in the clean room that they use the fume mode. This is the fume mode facility. You can see behind me also same the fume mode. Me also that's it in the fabrication lab. This is also I have the fume mode in my lab. So this fume
It
mode
protects
uh,
me from any
this
sort
fume
of
mode they have
aerosols,
used to
pathogens, and
make
other
the clean the
biological
vapors, to
spills.
put the
Say I'm
samples
using a
in
pipette and
the
then
petri dish,
I'm trying to use
and
a liquid
for the
sample.
clean environment.
You
Like that,
don't
we have to
want
use the
that
acetone,
spill
methanol, and
to
IPA.
infect you,
This
and that is why
foam
we
are
have the
dangerous
safety
to our
sash.
health.
And
If we
this
have inhale and
sash
exhaust the
level should be restricted to
ethanol and
the
acetone,
safety
we
line
have to
here.
maybe due to some times regular
As you
exposure,
can
we have to
see
cancer
here,
some.
safety
So
line
here mentioned that
with
some
a
dangers
warning
for
symbol
this.
which says
Till this we
danger.
can now
So
open
what,
that door of the fume mode
when you are
on this
using the sash,
position,
when you are
and
using
there
the
is
safety
one
cabinet while
motor
you
will be installed
work,
on order. It will
make
take the
sure
vapor out
you
through
keep
the
the sliding
atmosphere.
sash on the
So
safety
we have put
line
the hand gloves
during the
that
operation and do
apron
not
when we
impact the
working in
glass
the
to
clean
avoid
room,
damage.
and
So,
this is the warning
so
they
when
have
you're
to use.
working, ensure
This
that
that
you have the sash
this that
lifted
cursor have to
only
see it.
up to this
This is
line
that
here.
pipettes. We have
This
to take the
has been
drops of
designed to protect the
materials through the
person
pipette. We
from
have to
any
drop
sort
that.
of
Like that, we
contamination.
have to
So,
spin coat the
when assume I
photoresist
would
on the
like to
vapor. So
work
through that we take
here
the
in the
photoresist through
biosafety
that this
cabinet.
pipette,
So
and
when
then we
I'm
have to put
working,
the
I
drop on the
ensure
silicon
that
vapor,
this
and
does
then we have
not
to
exceed the
move the
limit, and I
run
limit
the
my
spin coaters.
this.
So
For
here see that
instance,
she open that
when I
position
have
till now
this
that on
device
that safe
box
side
here,
position,
this is
and now she
actually
open that
restricting
this
the air
equipment.
grill here. So that the hairnet. Again, even before I use the BSL hood, I need to ensure that I have my eye gears. So now these are the eye gears which I'm supposed to use even before I start working using the biosafety cabinet. Now that I'm having the eye gears on, now always ensure that all the equipments or the things what you need while you work are available even before you start working using the BSL hood. Now here we have two options. Even before we start working, there is a UV light source option here. So yes, now as you can see, this is the UV light. The UV lamp is mainly provided, the switch here is to turn on the light source which is inside, just to sterilize the entire work environment when the device is kept idle. So once
So why we use the UV light? Uh, because UV light will be like that in the COVID we have to disinfect the instrument. We have the UVC light, so it will be disinfect all the bacteria and all the molecules and particles will be present in that fume mode. We have to remove through the UV light. Okay, so that's why the fume would have the facility of UV lamp of the wavelength of the 365 nanometer or like 254 nanometer, 300 nanometer, and where we have to on that UV light, and it will be disinfect the our fume area. After that, we have to start the working. So this is the clean room facility during the fabrication of sensor. See that he have on that UV light. This is the LED light they have used, and they have to she has closed that fume mode shutter door. And after that, because when we have to come in the exposure of UV light, maybe we have to create the skin cancer or our skin will be burned due to the UV. It will harmful for our also. So we have to wear that apron during the operation in the clean room, and we have the use the head cap so our hair will be not fall in that any vapor or any substances. We have to use the gloves, so whatever the impurity particles we have in the our hand, it will be not to transfer in the our devices. So this is the all the instruction of the few mode that we have used. Whenever you have to do experimental work, you have to read more about on that. And this is the video that you can go through that clean room equipment, impedance analyzer, LCR meter, micro manipulator, what of the equipment we have used. See that this is the LCR meter we have used. This is the probe station. These two probe to take the electrical contact. See that open the test leads, select the choice to continue. What are the frequency we have to choose? We have this this meter. This is again that they have the workbench. In chemistry lab, you have to see in that workbench, optical microscope and everything. So whenever you have to go through video, you have to expose more about that. What things in the clean room, the facility we have to require to our fabrication process. Anything else?
No, sir.
Any doubt? In the quiz, you have to submit it. Assignment, you have to submit it. You can ask to me. Any topic related, any quiz. Have you submitted a quiz 1, 2, 3?
Yes, sir.
So any doubt in that quiz questions, because you have to appear the exam also that in month of April, and question will become of the same type of like that.
Sir, exam pattern will be.
Yeah,
Sir, exam pattern will be
same
multiple choice or
objective type. It is MCQ type questions will become in your exam. In maybe it will happen in the end of the April. So any doubt? Have you what marks in your quiz? It is 10 out of 10 or hello? Have you got your marks?
Yes, sir.
So it is
So it
10
is
of
10 of
One is 100 also, and 60, and another I forget. 60 and 100, two is.
okay.
okay.
Any doubt
Any doubt?
that easy or
Easy or
difficult?
difficult?
Quiz is easy or
Easy or
difficult?
difficult?
Easy, sir. Easy.
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 Okay, okay.
Okay, okay.
Anything else? Any questions, your doubt, personal, professional, you can ask to me regarding this subject or another subject, or in next class you want to include something different. So maybe you more understand the things. I can include that. I need your suggestions, feedback. Okay, then we meet on next Monday again, same time, 7 to 9 o'clock, for week 4 sessions. And I hope you will be join, and maybe you will come with your doubt, whatever that doubt in the subject. And you can post me your doubt on that ask two questions form that swam portal here also. Uh, that one form is on the swam portal is that this is about ask a questions. So maybe we respond on that also that, or I will include either I will respond on email directly, or that through that on the classroom also we can include that. So like that he will be asked that weight etching. He will be asked that weight etching that. So you can post questions like that on that email also that what is vapor. So you can ask that questions to me also. That so I okay.
Okay, sir.
So I will respond on that email also. You can post your question here also, or if I possible, I will take in the class also that. If I'm not able to answer your here. Okay. Thank you. Bye. Good night. See you
Thank
again.
you, sir. Thank you, sir.